Welcome to Ask and Learn.
We're going to sketch the graph of the function natural logarithm of x for x greater than 0 and less than or equal to 2. With that graph, we find the absolute and local maximum and minimum values of the function. So we know that the behavior of the natural logarithm when x is positive and close to 0 is that the natural logarithm becomes very negative. That is, uh, it takes larger values of magnitude and negative, and they are negative. So it means that the limit from the right of 0 of the function is negative infinity. That is, we have at 0, at 1, we have natural logarithm of 0, and then this function is doing something like this. That is, it's approaching, let's read a little bit better, it's approaching the y-axis more and more as x is more and more uh, or is closer and closer to 0. So there is no intersection, we know, between the line and the graph of the function. That is, natural logarithm of 0 is not defined, but there is always a behavior of getting closer to the y-axis. That's for that part. And now we have the natural logarithm is positive when x is greater than 1. And we have this value of, let's say, at 2. And that value, natural logarithm of 2, is about 0.69. That's the value here. And because we have included the value 2 in the domain, this point here in the graph got to be included. And we draw a field or circle. So we have this behavior here. And we can see it here a little bit smaller to understand better. Something like this. We have an asymptote, a vertical asymptote um, at the y-axis. That is, the graph is approaching, it's getting closer and closer to the y-axis from the right, never touching it. And at 1, the natural logarithm is 0, and at 2, we have the natural logarithm of 2, which is 0.69, more or less, an approximation. That's the behavior of the graph that we look here up a little bit bigger. Okay, so this is the behavior, and now we can get from this graph that f has, or the graph of the function has a highest point here. So f has an absolute maximum value. That value is natural logarithm of 2, which is approximately equal to 0.69. And that value occurs at x equal 2, that is at the right-hand point of the interval, which is included in this case. F has no local maximum because inside the domain there is not a point which is locally the highest value of the function. So we have this, and with respect to the minimum, there is no local or absolute minimum. F has no local or absolute minimum. And that's because this function is always always increasing. That is, it's always having greater values and is getting closer to the x-axis. So it's never stopping getting closer. It's never stopping getting bigger in magnitude, but negative. For that reason, there is no smallest value possible for the function or a lowest point in the graph. It's always getting closer to the axis and getting to negative infinity. So these are the properties of this function. Natural logarithm of x for x positive and less than or equal to 2.